Welcome. NOAA has just released its May of 2023 Global Climate Update, and this video is a summary of that report. The main takeaways from May 2023 is that El Nino is coming and it could be a strong one. May was the third warmest May in 174 years, and that makes 10 Mays in a row that are the 10 warmest Mays on record in that period. And the chances of that happening randomly are about 3.6 million to 1. Antarctic sea ice was at its lowest extent ever recorded, and carbon dioxide reached a new record high level in the atmosphere of 424 parts per million. Let's take a look at the temperature distribution continent by continent. North America had its hottest May on record, as did South America. Europe was above average. Africa was the 8th warmest May on record, as was Asia. New Zealand had its hottest May on record. Meanwhile, Australia had its second driest May on record, and Pakistan had its second wettest May on record. The Southern Ocean was the hottest ever recorded, and the Northern Oceans were the second hottest ever recorded. So let's make some comparisons. On a global basis, the temperature anomaly for the whole planet was 0.97 degrees centigrade, which, as I said, made it the third warmest on record. Land was at 1.25 degrees centigrade, the 8th warmest, and ocean at 0.85 degrees centigrade, the warmest. Now, it's interesting to note that the land is warming up faster than the oceans. That is to be expected. Let's compare the northern and southern hemisphere. Overall, the northern hemisphere had an anomaly of 1.17 degrees centigrade, which made it the second warmest on record. The southern hemisphere had 0.77 degrees centigrade, which made it the fourth warmest on record. Let's take a look at the last 174 years worth of temperature records for the month of May. This is the temperature anomaly over that period of time. You can see there's three distinct phases into this. So let's take a look at them individually, breaking them up into 60-year blocks. The first 60 years, that's 1850 to 1909, there was actually a slight cooling trend of 0.02 degrees centigrade per decade. In the middle 60 years, we had a warming trend of 0.07 degrees centigrade per decade. That's from 1907 to 1966. However, the last 60 years show a much stronger warming trend. That's 1964 to 2023 of 0.17 degrees centigrade per decade. And if you look at the most recent couple of decades, that trend is near 0.2 degrees centigrade per decade. That makes the last decade the hottest decade on record. You can see the little box there. There is no point on the graph that are higher than any of those 10 points. That makes us outperform both the medieval warm period and the Roman warm period, and is rivaling at least the climatic optimum of the Holocene, which was about 8,000 years ago. If we warm any more, and we likely will, this will mean that this will be the warmest period in the last 130,000 years. We have to go back to the previous interglacial, which was slightly warmer than this on average, to find temperatures equivalent to what we are having now. Well, the big debate is, are we warming or are we cooling? If you have a particular temperature range for your particular area, you get a curve something like this. This is a normal curve where your average temperature is represented by 0. You get some periods of colder weather, that's the blue area, and some periods of warmer weather, that's the red area. What happens when the average temperature goes up? The normal curve shifts to the right. So that means on average you're going to get more hotter than average temperatures and even some extreme new records set, and fewer colder than average temperatures and very few record cold temperatures set. So actually, what is the situation? Here is the percentiles map for this last month of May. And you can see that most of the plot is red. That means warming. Now, if you have record warming, you get this very dark shade of red, and you've got that in Canada and off the west coast of Europe and Africa. You don't have any record cold areas. We do have some much colder than average. For example, Antarctica is particularly cold. Central Australia and central India seem to be suffering from lower than average temperatures. But all in all, if you look at this map, the impression you get is that there's much more warming going on than cooling. That indicates that the planet as a whole is actually warming. With warming temperatures, we're losing snow and ice. This is a plot of the Northern Hemisphere snow cover over the last 50 odd years. You can see there's a distinct and strong downward trend of about 0.78 million square kilometers per decade. This is why so many ski resorts are having problems maintaining a viable ski season or a reliable ski season, and they're having desperate problems trying to find places to site the Winter Olympics. Let's take a look at the Northern Hemisphere sea ice. That's basically the Arctic sea ice. Now there's a lot of variability here, but there's a general long-term trend that's quite easy to see. That's the red line. Well, on average, we're losing about 2.5% of the Arctic ice every decade. And that trend does not seem to be slowing very greatly. Let's compare that to the Southern Hemisphere, the Antarctic sea ice. Here you can see no real trend over the long term. However, the last 10 years, there's been a very sudden drop in Antarctic sea ice. And in fact, this last May, it was at record low levels. Well, let's take a look at the global picture by adding all these different factors together. And you can see overall there's a downward trend of something like 1% per decade in global sea ice. And this last May was the second lowest on record. When I started putting this report together some time ago, we were in an El Nino watch. That has now been changed to an El Nino advisory. And it looks as though for the rest of this year, we're going to be in an El Nino, and it's going to be a strong one. So we can expect global temperatures to rise sharply throughout the year. Atmospheric levels of carbon dioxide continue to rise. In May of 2023, we reached 424 parts, which is the highest level recorded so far. May of 2022 was 420.99, so we've had an increase of 3.01 parts per million, which is very similar to the increase we had last month. Let's take a look at US temperatures for the month of May. It seems that the western two-thirds of the country had above average temperatures, with some records being set in and around Washington state. The eastern seaboard had below average temperatures for the month of May, but no record low temperatures were set. Let's take a look at US precipitation for the month of May. It seems the western half of the country had somewhat above average rainfall, whereas the eastern part somewhat below average. We seem to be setting a record low rainfall in Pennsylvania and Maryland, and I can tell you, being there, we have had about 12 inches less rain than we normally have by this time of year, and some of the gardens are looking pretty sad. Let's take a look at Western Europe, and particularly the seas around the UK. From this map, you can see that the temperatures there are extraordinarily high. This is a 4 degrees centigrade deviation from the 25-year average, which is an overall record for that area of the world. And the point is, we don't know what the effect is going to be on incoming storms to those areas. High ocean temperatures usually fuel stronger storms. So this is not a good look for the Western Europe for the coming months. For those that are still harboring the belief that solar cycle 25 is going to be smaller than solar cycle 24 and that we're trashing into a grand solar minimum, that hope is becoming more and more forlorn as time goes by. Here is the current status of solar cycle 25. You can see solar cycle 24 is there on the left. Solar cycle 25, we're about halfway up the rise phase of the cycle, perhaps a little bit more, and we're already equaling or exceeding the levels of solar cycle 24. So I'm afraid no grand solar minimum and no particular effect on the weather, and increased solar activity is certainly not going to help global temperatures to remain low. So what conclusions can we draw for all of this? We're in for a long, hot summer, unless of course some big volcano erupts. Now the reason for this is El Nino is here and it's shaping up to be a large one. Carbon dioxide is rising faster and solar activity is getting higher. The Earth is still warming too fast. 2023 is likely to be in the top 3 hottest years on record, some claiming now that it could be the hottest year on record, though I have my doubts about that. The period from 2014 to 2023 likely to have the 10 hottest years on record and maybe the hottest decade for over 130,000 years. This is not a comforting picture. Thank you for listening, and until next time, stay safe and goodbye.